Alright, our last segment of working through this activity, 112, is to talk about screws. Talking about screws, we are going to add a couple things to our formula sheet. So first off, threads per inch is something we need to understand, and then something else called pitch. So with a screw, you've got threads, right? Threads are really just an inclined plane that have been wrapped around a cylinder. Okay, in the end, it's going to be really important for us to compare two distances in the for the purposes of mechanical advantage and simple machine ideas. So one distance will be this distance of a rotation, so it'll be a circumference, right? And then the other distance will be a linear distance of getting something to move along the axis of the threaded rod. Okay, and we're going to want to compare apples to apples. So generally what we say is that, not what we say, but what's true is that exactly one rotation of this screw or threaded rod is going to create movement equal to the distance between two threads, okay, on the same side. That distance is given the name pitch. Okay, and how we understand pitch or find pitch in the US is often from being given a thread note that looks something like this. This is a very common 1/4-20 and maybe like a UNC note after it. Okay, this is a note to give us the size of our threads. The first part of it being the diameter. So this would mean we have a 1/4 inch diameter. So this is in the US in the US customary system. The 20 is the TPI, or threads per inch. So what that means, this is the important thing. What that means is if we had or looked at 1 inch of our screw, of our threaded rod, and then counted all the threads in here, it means you would have 20 threads per inch. So for every inch of length on the rod, you'd find 20 threads. Okay, so in terms of finding pitch, we go, well, hey, right, they're all going to be spaced evenly. So we really want to know just one little section. We'd say, well, there's 20 of them within this 1 inch. So let's take the 1 inch, divide it into 20 equal segments, and we'd say the pitch is 1/20. So pitch is really just 1 divided by the TPI. So these are a couple formulas or things we need to be aware of. We need to be aware of pitch being equal to 1 divided by TPI, and we need to know that threads per inch, TPI is threads per inch, and kind of how to get that. Okay? Alright, so let's look at the activity problems. Alright, so here we're going to look at number 26. And we've got this nut driver, so kind of like a screwdriver, but instead of a Phillips or flathead on the end, it's going to have, like a small socket. We've got a handle, like a regular screwdriver handle, and it's got this threaded bolt that we're going to be turning. So it says sketch and annotate the system. So I would draw something that looks kind of like a screwdriver. And maybe you've got, if you really want to get into it here, kind of like this, and then the bolt's going to go in here, right? Alright, so some information they gave us. I think this was a 1.5 inch diameter. This was a 1/4-20 thread. I think that's, what did they say? This was the driver was a 7/16 inch driver. I don't think we really need to know that, but there you go. There's some information for you. Annotated, okay. Sketch and annotate the system. So we've got the nut driver, 1.5 inch diameter handle used to install the bolt. Okay. Number 27 says determine the circumference where the effort is applied. So where's the effort going to be applied? It's going to be applied on the handle, and we are going to grab and twist. So what they want to know is what is the linear distance traveled with our effort with our fingers when we make one circle. So 27 is simply asking for a circumference. Circumference being pi times diameter. So in this problem it's pi times 1.5. That 1.5 was in inches, right? So what is pi estimated at 3.14 times 1.5? So 4.71 inches. All right. 28. This is determine the pitch of the screw. All right. Well, the threads per inch is what has been given to us directly in the problem. That 20 is the TPI, and pitch is simply 1 divided by TPI. So in this case it's 1 over 20, or 0.05 inches. 29 says, what is the mechanical advantage gained in the system? Okay, they didn't really specify. Did they say ideal? Well, I'm going to be finding the ideal because I've got the distances, which gives me ideal mechanical advantage. So ideal is dE divided by dr. Right? The effort is applied here at the handle, and the distance that's traveled is a circumference, which we've already found to be 4.71 inches. The distance that the resistance, which the screw is creating, the bolt's creating the resistance, right? It doesn't want to turn, but we're forcing it. The distance that we get, the direction of travel is a linear distance, okay, and it's going to travel exactly, one rotation is going to get it to move exactly one thread, or the pitch, which is only 0.05. So I'm going to put a P here for pitch, which is 0.05. So, right, almost 5 inches of movement out here creates a very small amount of movement. So that's going to give us a very big mechanical advantage. So 4.71, we're going to divide that by 0.05, which is really the same as multiplying by 20, right? Dividing by 1/20th is like multiplying by the reciprocal. So it's 20 times bigger. So 94.2. And no units, because those were both inches and they've canceled out. So that's our mechanical advantage. Now screws notoriously have a very, very large mechanical advantage ideally, however they also have a lot of friction, and so the actual compared to the ideal is going to be a pretty big difference. So they're not the most efficient simple machines. 30 says how much force can ideally be overcome. So this word ideally means we're going to go ahead and use the IMA that we just calculated, the 94.2, with the forces. If 5 pounds of force is exerted, so that's our effort force. So our regular ratio of force is FR over FE, which is really equal to the AMA. We're going to go ahead and put it with IMA because they've kind of asked what's the ideal or best case scenario. So we're going to say that the 94.2 is equal to an unknown amount of resistance force with our 5 pounds of effort. All right, so solving this equation is going to require just multiplying both sides by 5 to get the force of resistance alone. And so we've got the 94.2 times 5 is going to be what? Nope, I can't type here. 94.2 times 5. I don't know, something. 94.2 times 5. I feel like I mistyped. 471.